All right, welcome back to the next lesson in our distance learning environment. Last few weeks of school, we're going to be talking about exponentials and logarithms, kind of the last unit that we have to cover in Algebra 2. I'm going to break this week up into two videos. The first one is going to be kind of going over the definition, um, basic graphs. We're not going to do a whole lot of graphing on these things, and then just kind of converting back and forth because you've seen exponentials before. Logarithms are going to be new for you though. So as always, good idea to have a piece of paper and something to write with as we follow along. And there's one thing that you're definitely going to want to write down here in just a couple minutes. So as we get started, so let's go back to your Algebra 1 days and review what an exponential looks like. So remember the parent function was y equals a times b to the x, where that b, we called that the base, that was always greater than 0. It could be a fraction like 1/2 or something like that, but it was always positive. And then that a, we're not going to worry too much about the a. It's what we call the initial value, but we're not going to worry too much about a's. That we should be getting part of this stuff. If you remember back from the beginning of the year in Algebra 2, we talked about all the different parent functions. This is what the graph of that looks like. And remember, that has a horizontal asymptote at y equals 0. What else is in there? So again, if b is greater than 1, so 2 or anything bigger than 1, we call that exponential growth. And if b is between 0 and 1, then we call that exponential decay. Okay? And remember, just based on the graph, or if you remember that from the beginning of the year, we can talk about the domain and range of these things also. Okay? I'm not going to focus on this a whole lot. I do have a quick little Desmos demo that I want to show you just to kind of show you a little bit about that graph. So if we look here, here is the graph of b to the x, and you can see we did the transformation where if you slide it left and right, we can slide it up and down also, and all that good stuff. And then if you notice, the only thing b does, it changes kind of the steepness of it. And but the nice thing is, so like I had it here at 2. If it goes to 3, notice when x is 3, it goes to 3. And then if I change it to 4, it would be up here. So it's just kind of getting that little bit steeper as it goes through there. And then the initial value, that a that I talked about, that's really going to be your y-intercept. So the a can change to anything you want it to also. But I'm going to keep it here at 1 just to make my foot easier. Okay? I'm going to come back to that in a few minutes also when we start talking about the logarithm function. So what would happen if we took the inverse? So if my base, I'm going to make the base 2. If I just kind of did a table of values, there would be the values of y equals 2 to the x from -3 to 3. What if I did the inverse? Right? If you remember from last week, the inverse is just switching the x and y values, right? So if I switch those, then all of a sudden the first form becomes 1/8 comma -3, and so on. If I were to graph that, what would that graph look like? And if you remember also from last week, you should remember that the graphs of inverse functions are symmetric about the line y equals x, right? So if I graph that, this is what it looks like. This black line here, this black curve, is the initial graph, 2 to the x. And then this blue one is our graph of the inverse. Okay, now it has a name. We don't just call it the inverse of the exponential function. It's actually called the logarithm function, and it's abbreviated by log. In this case, we write this as log of base 2 of x. Okay, and you can see the points there also. They've reflected across that line y equals x. And notice there's a couple things that go on here. So my initial function has a horizontal asymptote. My log function has a vertical asymptote. Okay, and then the domain and range are also switched. So here the domain is 0 to infinity, and the range is from -infinity to +infinity. Okay, it does go up forever. I know it looks like it kind of flattens out here on the right, but I promise it does go up forever. It just goes up real slow. Okay. So again, you have to remember the inverse of the exponential is called the logarithm. Don't get hung up. I know it sounds like kind of a weird word and kind of a new thing for you, but it's just the inverse of the exponential. Okay. The function is going to look like this. It'll be log base b of x. There's a couple special cases we'll talk about in a couple minutes, but just like before, the base, that little b, that little subscript, is always going to be greater than 0. Okay. Here's your definition, and if you write one thing down during this video, please let it be this. The definition of a logarithm is this. So on the left hand side here, you see just our normal exponential, so y equals b to the x power. If you have that, then I can write that as a logarithm by like this. So log base b, so the base, same thing, of y equals x. Now notice the x and y kind of switch places. So let that soak in for a second. You need to pause the video so you can make sure and write that down, because this first part is just going to be converting back and forth. If you have an exponential, you need to go to write a logarithm, have a logarithm, write an exponential, and be able to use this definition to solve some very basic kind of equations. Okay? So a couple of examples just right off the bat. So if you have 2 to the third equals 8, obviously that's a true statement. What would that look like as a logarithm? Okay, notice my base is 2, my exponent is 3, and then my answer is 8. Well, if I write that as a logarithm, it's going to be log base 2 of 8. That answer becomes what we call the argument, and then the exponent becomes the answer. Okay, these two statements are equivalent. They're saying the same thing. Okay, let's do another example. So we got 10 to the fourth equals 10,000. How would I write that as a logarithm? So again, base is 10, so log base 10. The answer becomes the argument, so log base 10 of 10,000 equals 4. That was the initial power. Okay, and then one more. So 5 to the negative 1 power equals 1/5. We can do that from our exponent rules. I can write that as a logarithm. The base is 5, the argument is 1/5, and the answer is -1. Okay, so I'm going to do a bunch more examples here, and I'm going to ask you to pause the video to see if you can just write an exponential as a logarithm. Okay, so here's 4 questions for you. So go ahead and pause the video and see if you can write these 4 questions as a logarithm. Go back and use the definition and just write them. There's nothing to solve. These are all true. Just write them as a logarithm, and we'll keep on going here in just a couple seconds. Once you finish them up, restart the video. Okay, so that first one, again, the base is 3, power 4 equals 81. So that would be like this. Log base 3 of 81 equals 4. Second one, log base 2 of 1/8 equals -3. Remember, on all of these things, the power becomes the answer, becomes for the logarithm. Okay, so the third one, log base 5 of 125 equals 3. And then for the last one, now one thing I want to point out, if you remember from exponent rules a couple of weeks ago, 36 to the 1/2 power, how else could we write that? Now, that's the same thing as saying root 36, right? So, but this can also be written as a logarithm. We can say log 36 of 6 equals 1/2. Okay. Now, in the next slide, I'm going to ask you guys to go backwards. I'm going to give you a logarithm and see if we can write the exponential form. So here's 4 logarithms. See if you can write those as an exponential. Now, I did make one little note. I'm going to talk about more of this in just 1 minute. But if you see log base 10, it's actually called the common log. But I'll talk more about that in just 1 second. So go ahead and pause the video. See if you can write these 4 questions in exponential form. Okay, so hopefully you have those written down. So the first one, log base 4 of 16 equals 2. So I'd write that as 4 squared equals 16. And again, all of these are true statements. Number 2, the base is 10, the power would be 6. So 10 to the 6 equals a million. The third one, log base 7 of 1/7 equals -1. So 7 is the base, -1 is the power. And then finally, 8 to the 1/3 power equals 2. And again, just as a review from the Exponential rules, if you see 1/3, I could have also written that as the cube root of 8. Would have been the same thing. Okay, so that's going to be part of the assignment right off the bat. It's just converting one form to the other, just to kind of get you used to that logarithm format and going back and forth with exponentials. Okay, but there's going to be one more thing we're going to do. We're going to use the definition now to solve some basic logarithms. So take a look at this problem here. So I got log base 2 of x equals 4. Well, what would x be? Well, we can use the definition and rewrite this as an exponential using the exact same process we did a second ago. So I can write this as 2 to the 4th equals x. Well, and then 2 to the 4th, we can just figure that out. 2 times 2 times 2 times 2 is 16. So x equals 16. And that's that. Okay, how about this one? What if I have log base 3 of 27 equals z? Well, again, writing it as an exponential, I can say 3 to the z power equals 27. And you can just think to yourself, 3 to the what power is equal to 27? Well, we know 3 to the 3rd, so z must be equal to 3. And then I got one more for you. See if you can do this one on your own. I'll let you pause the video for a second and see if you can solve that one. So again, write it as an exponential. So 5 squared equals 3x plus 4. Well, 5 squared is just 25. So 25 equals 3x plus 4. And we can just do some basic algebra to find what x is. So subtract 4 from both sides and then divide 3. So x in this case would be equal to 7. Okay. So you're gonna, on this first assignment this week, you're going to be just asked to convert back and forth and solve some very general, some very basic log equations and exponential equations to kind of figure out what those guys are. Okay. Now the last thing I'm going to talk about today in this video are some special logarithms. I mentioned it in passing a second ago, but there's 2 special cases. So first of all, the first one's called the common log. So if you have a base of 10, we don't need to write the base. This is the only thing that most of your phone calculators or older calculators can do. If you see a log cube, this is what that means. So I can write that as without the base. If you see just plain log, then the base is understood to be 10. Okay. The second special case is what we call the natural log, and that's going to be abbreviated ln. Okay, and that is an L, not a 1. So ln, that's when the base is e. Okay, and e is a special number. It's called Euler's number. It's also called the natural base. It's roughly 2.71. It's irrational, just like pi is irrational. The decimal goes on forever and ever. But really what this means is it's a log base e. Okay, now this is very useful in a lot of different applications, from population growth, radioactive decay, sound levels, the Richter scale for earthquakes. All of these things use natural logs and e. Okay. Really what you'll see is something like this. So if you see something like this says ln5, really what that means is it's log base e of 5. And just so you know, we can do the same kind of definition that we did before. So ln5 is about 1.609. So we could write that as an exponential if we wanted to, using the definition. So we could say that e to the 1.609 power is about equal to 5. Okay, so it's going to be the exact same kind of thing if you see ln or if you see log or what have you. Okay. So the last thing I'm going to put on the screen here is the definition. If you didn't write it down yet, for heaven's sake, write that definition down. And again, there's going to be the first assignment attached with this video is going to be just on converting and doing those simple solving. So if you need any questions, feel free to drop me an email. You can log into the Google Meet room. And if you have anybody else in Algebra 2 that's having a hard time, you might want to share this video with them. But I do hope you're well. I still miss you guys. Wish we'd be going back to school, but won't be until August. In the meantime, take care of each other, take care of each other, take care of yourselves. And again, please contact me if you need any help with anything. Until the next time, keep studying.